Alright, so we have, in this case, let's just assume that, okay, we have a missile launch is true, and then it'll start running this code here. Now, I have, remember in the in our C program, we have a 9-byte array set up in the interrupt. Right here. And when it gets up to 9 bytes, then it starts to 0 again. So it's looping around. So when we're sending bytes across the line from the host computer to the microcontroller, we need to send sets of 9 bytes. If we send and just continually send sets of 9 bytes, so that they load into that that buffer, that array we have on the microcontroller. If we get too many bytes or too few, then it kind of screws up the display, where it's going to display on the OSRAM displays, because there's 8 digits. There's 8 digits on the display, and then we have one additional digit for the missile launch code, which we don't display, for a total of 9. So what we've got to do here is I've got to create an array of 9 bytes, and using the chaff count, which in this case is going to be up to 3 digits, and the flare count, which will be up to 2 digits. So we have 3 digits on the we'll have 3-digit flare count, then we'll have the diamond symbol, we'll have 2 blank digits we're not using. We have to send the code to them to write blank so they don't show anything, and then the 2 flare digits. So what I've done here is create a set of basically a set of like 3 arrays. One for the chaff count, and then I have to put this filler array in. Here's the code for diamond, and then I put in these are for blanks, to write blanks to the 2 displays. Then I have that dummy, or I have that actual missile launch code coming in, and then in this array I have the bytes for the flare count. So right here, this line, first this line creates a byte array called ASCII values 1, and it takes it and encodes it using the encoding class in .NET. In the encoding class, or encoding get bytes method in the encoding class, we'll take when over in a derived class, when overridden in a derived class, encodes all the characters in a specified string into a sequence of bytes. So that's what we're doing. We're taking our first string here, which is the chaff count, and then encoding it, changing it into bytes, and then making this array, this byte array, ASCII values 1. That's for the flare count. And then the chaff count, and then the flare count, which I have equal to a string here. I'm taking the flare count from the reader class up here that I'm receiving, and I'm converting it to a string, and then I take that string and I use the ASCII encodings get bytes method to convert that string to an array of bytes. And here's the flare bytes. This would be the flare array created from the flare string up here. And then because we have those digits in between, we have the diamond, we have the blank digits, we have the missile launch code coming down the line, which we need too, and we don't want to print that. I create this third byte array manually to stick in between the chaff and the flare bytes. And then I take all three of these, and that's what this code down here is, taking all three of these arrays and combining them into one array. In this case it's called RV. And so that I come up with a 9-byte array, which I will then write down here. Right here was when I take that 9-byte array I just created from those other 3-byte arrays, and I write that 9-byte array RV to the port, send it over to the microcontroller. So that's a block copy. In this case ASCII value is 1. It's going to go to the RV, the new RV byte array, and this block copy method, needs the length. It measures the length of the array. And because, as you count, the problem is when you count down the flare, say you start at 180 and you count down, when you get to 99, you're now transmitting only 2 bytes instead of 3 bytes in this array. So that's what this second part is for. If the length of the chaff or the flare changes, you need to compensate by adding bytes into this middle array. Because, like I said, when you're transmitting 3 bytes in the chaff array from 180 down to 100, but then when you go to 99, you're only transferring 2 bytes, and then when you go from 99 to 9, you're only transferring 1 byte. Well, the MCU is waiting for 9 bytes at the other end. Over here, it's waiting for 9, and then it'll reset. And if I'm not sending 9 each time, that'll screw this up, and the display goes squirrely. So anytime it changes on the chaff or the flare, changes, the length, the number of bytes I'm sending changes, then I need to change this middle byte array to compensate. So that's what each one of these other things here are. Basically, I did short code here when I have 3 digits in the chaff and I only have 1 in the flare, and I have no launch. I'll send the 9A, so I use the 9A. I'll send a 9A if there's no launch. I'll send a hex 9B if there is a launch. So that's why down here, if there is a launch, I have basically a copy of all this other block copy and these arrays. It's the same thing down here. It's just that I changed the A to a B so that I can send the code to the microcontroller that there's no missile launch. There's probably a lot easier ways of doing this, but this is what I've stumbled through so far. Right here was a problem when I got, for some reason, when you get the flare count gets down to 0, it transmits a -1 in this value, in this string, and that was screwing up the display. I wanted to show it as 0, not a -1. So that's basically what this does. If T, the string T or the string S is equivalent to -1, then change that to 0. That's all that does. I could probably just take this string S and just get rid of the string S or string T and just put my chaff count string into here, get bytes. I haven't got that far. Check, see if that screws it up or not. But anyways, this works. So it extends the process a little more. But anyways, like I said, you got the remember you got the when you start up Falcon, check to see if it's running. Then it'll start sending you the code for the counts for the chaff and the flare. And then we take the chaff count, convert it to bytes, create an array for it. Take the flare count, create an array of bytes, and then manually I insert this third one so we get 9 bytes each time. So even though the flare count or the chaff count can change from 2 digits and 2 digits to 3 digits and 1 digit, or 2 and 1. I'm constantly compensating here, creating that 9-byte array and sending it over the line, just depending on you know, what value the chaff and the flare are going to. Hopefully that's somewhat clear, though it's probably foggy as. So just in so like I said, once I create the array, now this say in this case we have 3 digits. You know, it still hasn't gone from 180 to 99 yet on the chaff, but it did drop to below 10 on the flare. Then this loop will be implemented. That's what I'm checking up here. ASCII values 1 length, if it's equivalent to 3, or if the 3 byte array, which is for the flare, is equivalent to 1, it'll execute this loop. It'll create the 9-bit array here, myRV, and then it'll copy. Actually, it'll create each one of these, each separate array here for the chaff and the inserted one and the flare, and it will create a 9-bit array called myRV. Then it'll block copy each one of these into myRV array and create a new 9-bit array, which is then written. You can see me writing it out the port. It'll be 9 bytes in length, and it will go over the line, across the USB to TTL converter, over here, and come, and then it'd say, okay, we've got the first byte's coming in, interrupts triggered, it's read, it's dumped into the RX buffer. Then it checks. Have we got to 9 yet? No. So then the next byte comes in, triggers it. Byte 2 is dumped into the second element of the RX buffer array, etc. up to 9. And then as that array is being filled, remember we're cycling here in the main loop, and we're writing each byte to the display as it comes in. Remember, we got 3 on the chaff, the diamond, 2 blanks, and 2. Actually, this is an old method. I shouldn't be showing that one. This is it here: the 3 chaff, the diamond, the 2 blanks, the dummy for the missile launch code. It just increments, it moves the pointer along so it doesn't get out of sync, and then the 2 flare. Now this, like I said, is if if there's no launch code, instead of sending a hex 9A, I have to send a hex 9B. So I just wrote everything that's up here for the different 3 flare count, the 2 flare count, or the 3 flare count, and the 3 chaff count and the 2 flare count. Then it'll go to these loops. Basically, I had to write all these out just so I could send the 9B over and turn that missile launch byte off. You see all my attempts. I have a whole mess of different attempts trying to get this to work. And I think that is the basics of it. So let me, I'll just do the next, I'll stop here and implement, show you an example of the running program in the next vid.